Let's have a look at the reaction between ethene and sulfuric acid. Ethene is an alkene with 2 carbon atoms, so it has a formula C2H4. We can draw its structure like this. Notice it has a carbon-carbon double bond. H2SO4, or sulfuric acid, has this structure. Now notice the carbon-carbon double bond is got 4 electrons in a small space. That's an area of high electron density. That means there's a lot of electrons in a small area. And on the OH of the sulfuric acid, we've got a difference in electronegativity. The oxygen's more electronegative. That leaves a hydrogen delta plus and the oxygen delta minus. And the delta plus hydrogen is going to be attracted to the negative charge of the carbon-carbon double bond. And we're going to show a mechanism where the bond forms using one of the covalent bonds. So the electrons go to the hydrogen to form a bond to that, and then the OH bond breaks, and both of those electrons go onto the oxygen. So on that first carbon, we've now got 3 hydrogen atoms, because one of the hydrogen atoms has been added to it. But on the second carbon, we've still only got 2 hydrogen atoms. It's kind of like it's lost its electrons, so it becomes positively charged. We call that a carbocation intermediate. A cation, remember, is a positively charged ion. So a carbocation is a positively charged ion where the plus is on a carbon atom. And we're also left with a hydrogen sulfate ion which has this structure. Notice a negative charge is on the oxygen where the hydrogen was lost. And the hydrogen sulfate is an anion. That means it's a negatively charged ion. So we've got a carbocation which is positive, and a hydrogen sulfate ion which is negative. Remember, opposite charges attract. So the electron pair on that oxygen, the negatively charged oxygen, forms a bond to the positive carbon atom of the carbocation. So we draw that curly arrow. And that new bond basically sticks a hydrogen sulfate onto the carbocation to form a new molecule which looks like this. And we can call this molecule ethyl hydrogen sulfate. Now this reaction is an electrophilic addition reaction. And you can see other electrophilic addition reactions with alkenes too, for example, bromine and hydrogen bromide. Electrophilic addition reactions involve the removal of the carbon-carbon double bonds to make new molecules.